Okay, in this video we're going to practice some calculations of titrations. First one, I have 45.3 milliliters of hydrochloric acid is used in a titration against 83.6 milliliters of sodium hydroxide. So my volume of acid, 45.3, volume of base, 83.6. The molarity of the base is going to be 0.77 molar. The question is, what's the molarity of the acid? So I'm going to use my equation, MAVA equals MBVB, and I'm going to substitute in, that's the volume of acid, here's the molarity of the base, and there's the volume of the base. Solving for this, the molarity of the acid is going to be 0.77 times 83.6 divided by 45.3. Solving that out is going to give me 1.42 molar hydrochloric acid. So I was able to use my knowns to figure out my unknown. All right, next up, I have a 12.4 ml sample of 0.315 molar rubidium hydroxide. So that's going to be my base, and my acid is going to be 53.78 milliliters of acid. Using my equation here, MAVA equals MBVB, my volume of acid, 53.78, molarity of base, 0.315, and volume of base is 12.4. Solving for the molarity of acid is 0.315 times 12.4 divided by 53.78. Solving that out is going to give me 0.0726 molar acetic acid. All right, number 3. This one here, I don't have labeled quite as clearly, so we got to figure it out. So I've got potassium hydroxide, 53.7 mLs of the base is titrated against 32.8 mLs of 2.3 molar hydrobromic acid. So my molarity of acid is 2.3 molar. The volume of it is 32.8. My molarity of the base is the unknown, but the volume of the base is 53.7. Here's my equation. I'm now going to substitute in my knowns. Solving for the molarity of the base is going to give me 2.3 times 32.8 divided by 57.3. Solving that out is going to give me 1.32 molar potassium hydroxide. All right, this next one here, my volume of acid is going to be 20 mLs of 0.01 molar aqueous hydrochloric acid. My volume of the base is 30 mLs. The molarity is my unknown here. Again, using the equation, I'm going to substitute in the values that I know. The molarity of the base is going to be the unknown. 0.01 times 20 divided by 30 is going to give me 0.0067 molar for my base. All right, now this one's going to be a little bit trickier because what I'm going to be looking for here is not the molarity, but the normality. So I'm going to start with the volume of my base, which is going to be 24.33 mLs. Now, when I take magnesium hydroxide, that one here is actually going to split out. I'm going to get 1 magnesium cation and 2 hydroxide anions there. So for each mole, I'm going to get 2 moles of the hydroxide. So 0.045 molar is going to actually be 0.9 normal. I got to multiply it by 2 because that's my conversion there. The volume of acid, 55.13. So now I'm going to use the same idea, but instead of the molarity, MAVA and MBVB, now I'm going to use normality of acid and the volume of acid with the normality of the base and the volume of the base. Solving it out pretty much the same as before. Put in my known variables. Solve for the normality of the acid, 0.9 times 24.33 divided by 55.13. That's going to work out the normality of the acid is going to be 0.397 normal. Now what we need to do to figure out the molarity, I need to look at this, and I'm going to know that phosphoric acid is a triprotic acid. For each mole of this, I'm actually going to get 3 moles of my hydronium cations. So I'm going to take 0.397 normality, which is almost like artificially inflated because it's phosphoric acid. I'm going to divide that by 3, and that's going to work out to be 0.132 molar phosphoric acid. So anytime I'm dealing with normality, you have to think because it's a di or triprotic acid, it's almost artificially inflating its concentration. Dividing by that equivalence factor of 3 is going to get me back to the molarity. All right, last one. Volume of acid, 67.35. Sulfuric acid is a diprotic acid, so 0.45 molar is actually going to work out to be 0.9 normal. My volume of the base is 48.97, and the normality is the unknown. Here's my equation. I'm going to substitute in my known variables. In this case, I'm going to be solving for the normality of the base. Normality of the base is going to be equal to 0.9 times 67.35 divided by 48.97. Going to work out to be 1.24 normal for my calcium hydroxide. Now, calcium hydroxide, that one, for each mole, I'm going to be getting 2 moles of hydroxide. So again, I need to divide this one by 2 to give me the more accurate one, which is going to be 0.62 molar calcium hydroxide.